Hello everyone, back here once again, and today's topic will be super basic networking and IP addresses. Alright, so what is an IP address? Oh look, that's an IP address. So IP stands for Internet Protocol. So IP address is Internet Protocol address. You can kind of think of it as like a street address, except it can get more advanced than just a street address. Alright, so let's break this down. Alright, so what this is numbers. Alright, okay, like you didn't know that already. So what these numbers mean, this one means like what country, what region, kind of like are you in like Europe, America, whatever, and then these is just more specific, and it gets even more specific, and it gets down to here. So that's even more specific. Right. So there's two. When you connect to the internet, most likely, whether if you have a router or not. This depends if you have a wireless router or not, whether you're connected to it. You might not even be on Wi-Fi, but depending if you have a wireless router or not. So if you have a wireless router, then you technically have two IP addresses. You have your public one, which connects from, say, Joe Smith's computer to your household internet, which is your router. So it connects that to your router, and then to your specific IP address within that router. Now within that router is an IP address, and then the only difference between, say, computer one, like say the kitchen computer, and say your bedroom computer or living room computer or whatever, is this one right here. This number right here. It'll change depending on what range you have it set on. So for my household, my computer is 100, my other one is 101, so I have one that's 100, I have one that's 101, there's 102 is my other one, then my mom's I think is 103, then my network, different internet devices, are so on and so on. So that is an IP address. So say I want to go to google.com. So I type in www.google.com and I click on it. So what it does, it goes out to what's called a DNS server. So let me explain what a server is if you don't know. So there's two kinds of things on the internet: servers and clients. You can think of a server as like a really big computer. Mainly is big computer, it can be any computer that hosts a certain file, whether it's a web page, whether it's a FTP server, which is file transfer protocol. So if you want to download files, whether it's a video sharing thing, anything, mainly web pages though is what mainly you would know as a server. So Google has their servers. So when I go and be like, hey Google, what's up, I want to access your homepage, so I type in google.com, and then what that does is, let me open up a new one here so I'll show you. Alright, so let me go over here. Alright, bigger. So you have the client, so I have me. Alright, I want to go access, and then my thing back over here is my ultimate goal is to go to google.com. Google. Sorry, my mouse is pretty sensitive. It's a rat 7, if you know what that is. So I want to go to Google, so I go there. But before that, I have to go to what's called a DNS server. DNS server. Alright. So what that is domain name service. So what that is, what a domain name is exactly what you see right here. It's this name. This right here, www stands for World Wide Web, if you don't know that already. That's in every single HTTP hypertext transfer protocol HTTPS is just means that it's secure. So you don't need that when typing in. All you need is www dot the name, and then you have the ending right here .com. It could be .org, .net, .biz, .uk.com, .blah blah 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 .com. There's many different endings that you can have there. All right, so you have me. So I go here. So what this looks up is what IP address, which is, if you remembered that number, so which computer has this name google.com associated with it. So it looks it up. So it goes, so you have this big chart, more or less. Alright, I'm trying to draw straight lines here. So Google, I'm just gonna do, okay, that means Google. So Google is blah 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 dot blah 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 dot 307. I don't know, I'm just making up numbers. Alright, so it says that it's like, okay, Google is this IP address, sends it back here, and then it transfers it. It's like, alright, so that IP address goes to Google. Yay. And then this huge process right here, this long arrow, it's not just that, there's many more processes. When you request something, it doesn't go straight there. What the internet is here, I'll draw boxes. So what the internet is literally, it is a mesh of servers and clients. So what a client is anything that requests information. So my computer is a client. Server is something that hosts information, like say a web page, and then the client. So literally what the internet is a whole bunch of servers talking to each other. So it is what we call a mesh network. So this mesh network, when you send it out, it doesn't go, it's not going to go just directly to there. There's no direct route to google.com. So say it goes in here, all right? Goes in right there. So this arrow. So it goes here. Then it will, and then say this is Google right here. So there's a few possible routes that it could go. So it could go here, and then it might bounce off of here and go there, and then go there, and then there. Because if it only went one route, say there's like a cable got cut, or like some internet is down somewhere, right? If it goes there and then just hits this block, then what? You can't go to Google just because some random line in, like, say India is down or something because a car crashed into it or whatever. I'm just making up some random scenario. No, so because what it does, it goes and it pings off other servers to try to get to this ultimate destination of google.com, the server. So just because say the server is down or something, or this thing is down, so it could still go here, bam, go off here. Let me add a couple more arrows there. Alright, so it could go here, go there, it could go here, here. So there's not just one way of going, but it doesn't go on forever. It's not like like bouncing off forever. There's a certain amount of times, like it goes to the internet to like it'll go and bounce off certain many times, because if it didn't, then it would literally be an infinite amount of pingings, just like we're trying to request information that you may or may have not already gotten. So blah blah blah, it goes there, it goes to Google. Then Google's like, this is usually how it works. There's certain instances and certain protocols that it's not how it works. So it's called SYN, SYN. So that's SYN. So then it's like, all right, you're the one that requested the information, say google.com. So you want to So you're the computer that wanted it, right? And then your computer is like, yeah, I wanted it. I want that information. So so this is called, I think I spelled it right. So the next step is called synac. So it's like, yep, I want that information. So Google, so it's like, you want the information? Yep, I want the information. So then Google sends the information, the requested web page, back to you, thus giving you a web page. Yes, that is a lot more than you might expect of just going to google.com. Alright, so I did a little demonstration here saying, so you don't have to put in the domain. You could put in the IP address. So this is Google's IP address. So if you look here, same exact thing. There's just some things that aren't the same just because I connected to the actual IP address other than the google.com. Most likely it'll be the same exact thing. There shouldn't be any difference. So if you want to look up an IP address of anyone or see if it's online, type in CMD. That will bring up command prompt. Then type in ping, then say www.google.com. So I'm pinging it with what is called packets. I'll explain that in just one sec. So it says reply from, it's pinging www.google.com, and then it gives the IP address, and then it says reply from the IP address, which is google.com, with the amount of bytes, which is the size. How long it took is measured in milliseconds. If it's anything more than milliseconds, then you really have a slow computer and should think of upgrading from a messenger pigeon. And then that's pretty much all you need to. So this is how long. So 18 milliseconds. That's that. And 13, and then 16, 15. That's a pretty good average, actually. So what a packet is, let me do a new one. Alright, so what a packet is, you can think of it as like a mail. Alright, so you got IP address here, you have your, I'll just put U, or a Y, sorry. So that's your IP. It's not exactly how it is, it's not a mail, it's actually like a string of code that is certain format. So little cute little stamp here. There's really no stamps. Alright, that's an ugly stamp, I'm sorry. So you have your stamp, whatever, picture of a president on it. Alright, so you have your IP address, you have the IP address that you want it to go. So destination D, I'll just put D. DIP, it's kind of hard for me to spell. So you have your destination IP, you have like a protocol, just put pro, your port, I'll explain that also, like what port you want to connect to, and then like I guess what do you want to access, because I can host multiple things off one server. So there's not like one web server for every web page. It's like, what you want, bro? What you want, bro? Alright, so you have your IP address right here. Sorry, can't see that very well. So when you send this out, you have the destination IP, which is Google, after the DNS lookup. If you typed in like www.google.com and not the IP address, so it has the destination IP, where it's going, who it's from. So obviously when it gets there, it's like, okay, so if you don't have that, it's like, okay, what do I do now with this? Like, where do I send it back? I'm not just gonna randomly give information at some random IP. And then the port. So what a port is, you can think of it as a wall with holes. Alright, So what a port is, there's ports ranging from like 1 to tens of thousands and crazy number. So but there's ports that are reserved. Most ports are unofficial, like whether it's a game or an application or something, but some ports, there's different ports that is specifically reserved for something. So alright, basic ports. Port 80 is HTTP. Port 80 is HTTP. So when you access a web page, here I'll look it up. Common ports. So when you access a web page such as google.com, it is going through what is called port 80. Right. Here we go. This can be very useful. Alright. So port 80. Let me look through here, see this. Alright. So another one that you will need to know is SSL 443. SSL is security link or something. I forget. Secure link. I forget exactly what it stands for. But what it is, it's a good encryption that uses like when you like type in your banking account. PayPal uses it. Some websites, pretty much any website with a transaction will use it, or at least should use it. So it's pretty much when you send it out to, say, like the store. I'm going to put a present to get your present. Right. So when you send it out and your packets are going out, right? What SSL helps you do is, so in case there's like a bad guy in the middle that's reading your packets, which is called packet sniffing. So it makes sure that if a guy in the middle intercepts your packets before it gets to your destination, that it's all encrypted mumbo jumbo. Because there's the encryption is something later, but pretty much it makes sure that the other person cannot read it. Because if the other person could read it, then they can easily see passwords, and they can easily see other bad stuff that you might have, like credit card numbers that could be really, really bad if you ever had that, like, to some random person. Alright, so remember we did DNS. DNS is 53. So when you search up www.google.com, it does a DNS lookup of that, and it's like, whoa, look at that, blah 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 blah. Alright, I think that's pretty much all of that you should know. There's like Jabber and iTunes and Messenger and stuff, Xbox Live and stuff like that. But so if you ever have something not working, says it cannot connect, it might be that the port is closed on your specific server. So if you're at school or in college at all, and something won't let you connect or whatever, then it might be that the admin or whoever is controlling it blocked the port. So just something to keep in mind if it's like a program, like, so they don't want you playing League of Legends or anything at your school, so they just like block the port so you can't ever connect to it. So thus you cannot play it. Good workaround. That's good. Alright, and then briefly, IP addresses. So this is not my IP address. I do not live in the United Kingdom. If you search that up, I'm using an IP address hider, also known as a proxy server. And then this is IPv6. So explain. I know this video is going really, really long, and I'm very sorry for it, but I really think that you should know this. So what a proxy server is, me, and then G for Google. Alright, so I go P for proxy, and then Google. So my request goes through another server, which has another IP address. So mine might be 0.2. I'm not going to write out the whole thing. This one might be 0.3. So Google reads it and it's like, oh, okay, so I'm going to send it back to this IP address. And then once it goes here, it says, okay, who's the one that requested this one? Oh, look, it's 0.2 that requested it. So they send it back to me, thus giving it through this IP address. So when I look up what's my IP on what'smyip.org, or what'smyip.org, yeah. So it says your IP address is blah blah blah. This is actually not my IP address. I'm not going to give my real IP address out. You don't want to do that. People can track you. It's kind of dangerous. And totally hack your computer if they feel like it. So this is a random IP address in United Kingdom. Go ahead and hack it. I don't really care. Go get arrested. So when I request for that web page, it goes through here. It goes through here, and it's like, okay, let me see. Oh, look, your IP address is blah blah blah. Remember that the packet thing with the destination IP address, and then this one again does like pretty much repackages everything it gets from this server into another packet, more or less, with my destination request. So it's pretty much like accessing two web pages. It's like accessing google.com off your friend's computer through your computer. So yeah, that's what a proxy is. And then one last thing, there's IPv4 and IPv6. So IPv4 is that number 1 is blah 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 dot this is here. I'll show you the maximum that anyone can have. Dot. Alright, so that's the maximum. There you can. It's 1, 3, 6, 9, 12. So it's 12 characters long. Can range from anywhere between 1. It can be zeros too. But if you have like 0, 0, 1, and then like 0.1, there's absolutely no difference between them. We just say 0.1. So it's 1 through 9. So there's something like there's like one IP address for every like one person on the planet, or like 2 people on the planet, something like that. It's only in the billions. But what IPv6 is this. This is what IPv6 is. It's 4 4 1 2 4 4 4 4. It's much longer. I believe it's 24. But it consists of a set of commas, or I mean dots, my bad. It's semicolons, and it can be letters and numbers, so that drastically increases it. So instead of 1 through 9, it's 0 through 9 plus 24, or sorry, plus my bad. So let me see this. Yeah, I'll just whatever. It's numbers. That's not even N. Really doing bad here today. Numbers plus every single letter plus even more spaces. Alright, so it's the numbers plus the letters plus even more spaces. And there's this insanely ridiculous number. There's like each person alive can have something, I think it's like in the octillions of IP addresses for them. It's literally never gonna run out. That's what we said about IPv6, and kind of the weird thing is we technically didn't run out. The federal government has about 280 million IP addresses that they control. Hundreds, thousands, billions. Yep, millions. They have about that many million IP addresses that they've bought. So there's like 3 to 4 billion. There's like 3 billion IP addresses in the top 10 owners that still are not used. But 2 to 3. That's quite a lot of IP addresses that are still not used. It's like 2 billion. It's insane. They bought, because they sell them in like lots. So once they buy a lot, so all the lots are technically bought out, but they still use it, and we're converting over from IPv4 to IPv6 in the process. Google has now IPv6 up on some of their websites. Most websites are not yet converting because not everyone has it. It's a complicated process, but hopefully that answers all your questions about basic networking. I'm very sorry this video is super long. I might break it up into 2 parts. If I already did, I already did. If I didn't, I didn't. But yep. So I will do other videos on networking, and I hope that you actually guys learned quite a lot. I know I had to learn this all by myself, googling it, just messing around with my computer. So I know if someone told me this, that I would be super knowledgeable now, and I hope you guys are knowledgeable in this right now. And sorry, no, you're not gonna see my real IP address. So once again, like I always do, I hope you guys have learned something good today, and thank you, and have a very nice day. Sorry for wasting a half hour of your life or so. See you later, guys.